All right, hello everyone. So in this video, we'll be covering how to find the absolute maxima and minimum of a function f of xy equals xy along the circle, or something we call it a constraint, x squared plus y squared is 10. All right, so in order for us to solve this, we're going to be using the method of Lagrange multipliers, which says that if you have a minimum or maximum value on a constraint, such as we have here, it has to satisfy the set of equations you have in blue. The gradient of f equals lambda times the gradient of g, where lambda is a real number, and g of xy equals c. Now, the first steps here are to find a gradient of f, which is the vector that you form when you take the partial of f with respect to x, which is y, and then comma the partial of f with respect to y, which is x. Then we need to find what g is. G is basically the function that's on the other side of the constant, x squared plus y squared, and we take the gradient of that as well, similarly 2x comma 2y. And then what you do is you set up an equation where you have one gradient, the gradient of f equals lambda times the gradient of g, and the constraint that is here. And if you make it into, you further break it down into a more explicit system of equations. So you would have, if you set the coordinates equal to each other, y would have to equal lambda times 2x, and then x equals lambda times 2y, and then with our constraint. So we have three equations, three variables, and technically you have to solve this system for x, y, and lambda. Now, how do I go about doing this? This is where the hard part is. The calculus is really the easy part, taking the derivatives of partials and all. So basically a lot of things go here. There's so many methods that I can't really speak to that here. Usually I tell people just look for the clearest thing that you see, and what I'm thinking here myself is that I can substitute maybe equation 1 into 2 or 2 into 1. So for example, if you take equation 2, x equals lambda 2y, I can substitute that in here. And if I did that, I'd get y equals lambda times 2 times lambda times 2y here. That's a handful. And I can go ahead and simplify that to say y equals 4 lambda squared y. And I can move that y over, so I can factor and use the zero product property, which tells me that y equals 0 and lambda would equal plus or minus 1/2. So if y equals 0, I can put that into my constraint equation and get a point, plus or minus root 10, 0. And I can do the same thing with lambda equals 1/2 and negative 1/2 in the sense of substitution. So if you take lambda equals 1/2 and substitute into y equals lambda times 2x, you would get 1/2 times 2x, y equals x. So you get x squared plus y, so you get, sorry, let me go back. You get y equals x, and I'm going to take y equals x and put that back into that constraint equation. X squared plus y squared is 10. If we do that, we get 2x squared equals 10, or if we solve for x is plus or minus root 5. So our solutions here would be root 5 comma root 5, because if x is root 5, y has to equal x according to this right here. And if y equals minus root 5, then the y value would equal negative root 5. So these would be 2 points that we're going to consider. And what we're going to do with these points, along with some other ones, which we'll cover in the second part of this video, so we're going to plug those points back into your function here. Okay. All right. So we'll cover when lambda equals minus 1/2 on the next video, and then we'll keep working on this problem. Thank you for your time.